Good morning, Geometry Honors students. So Mr. Chen again. So just want to talk about that section 1.5, division of segments and angle. So the objective, identifying midpoints, bisector of segments, trisections points, and trisectors of segments. So this one, basically the textbook doesn't explain it that way. They put in like angle bisector or the angle addition postulates. So this one, it's going to be a little bit more in depth, okay? Because that is for geometry honors. And also for geometry, regular geometry student, you guys probably want to find out more extra concept, things that you probably don't see that from the textbook here. So definition, a point that divides a segment into two congruent segments, it's called a midpoint. So we talked about that previously. And record that the midpoint formula, it's always considered the quantity of x1 plus x2 divided by 2, comma, and then the quantity of y1 plus y2 divided by 2. So now let's look at that, some of the example here. So given that segment OM equals y plus 6, and then segment MP equals 3y minus 4, find the length of segment OM. So this one, back to the textbook there, is showing that it's a segment addition postulate, so which means that segment OM plus segment PM, so once you combine them, so that would be considered segment OP. Okay, so this one is given that OM, which is y plus 6. Okay, so you can always annotate it. And then MP, which is 3y minus 4. And you want to find out the length of OM. So if M is the midpoint of segment OP. So since we do know that M is the midpoint, so basically this one is saying that y plus 6 would be the same as 3y minus 4. Okay, because that segment OM is the same as segment PM. So by plugging that expressions, so set them equal to each other, so we just solve for y, going back to algebra 1, so solve for y, subtract y both sides, and then F4 at the same time. So basically this one gives you that 2y equals 10. So solve for y divided by 2. So we got y equals 5. So y equals 5, that's just a variable, but don't forget, we need to find the length of OM. So by plugging the number back to the expressions, so 5 plus 6. So then that'll be 11. So segment OM, then that'll be considered 11 units. So here's another definition. A segment divided into three congruent parts is said to be trisected. Okay, so trisect. So let's say that we do have an angle here. So once you trisect this, so we do have another two rays. So that means each angle here, they all consider the same as the other. Okay. So let's say that this one is angle A, BAC, and then we do have the other two rays. So let's say AD, and then AE. So basically AD and AE, those two rays, so they just trisect the angle BAC or CAB. Okay, so now to look at that one of the example. So B and C are trisections points of segment AD. So basically this one is saying that AB, BC, and CD, they're all congruent. And one thing that is given here, AD is 36. So the entire segment here, it's 36. So in order to get that AB, so basically this one we just need to divide it by 3. So AB, so basically just 1/3 times 36. Again, trisects. So that means you want to divide it by 3. So 1/3 times 36, so what we found here, which is 12. So that means segment AB, it's 12 units. So here's another one. AB, it's x minus 4. Okay. And then AE, so AE is given as 3x plus 2. Okay, so this one, let's see what we need to find out here. Okay, I believe that we have to solve for x if there's a perimeter given here. Okay, so this one is one of the interesting one. Yeah, I believe that this one, the setup, it's incorrect. So let me fix one thing here real quick. So this one is saying that it's not AE, it's supposed to be AD. Okay, so segment AD, then that'll be 3x plus 2. And then you want to solve for x. So again, so AD, so which is the measure of the entire segment. So this one, if you multiply by 1/3, then you'll get that AB. So AB is x minus 4. So basically this one is just solving for x. Okay. Okay, so 1/3. So what we can do, we can distribute, obviously. Another way you can do it, you can just multiply everything by 3, because you don't want to deal with the fractions. So multiply by 3 on both sides. So 3 times 1/3, then that's just 1. So what we found here is 3x plus 2, so that equals 3x. And then minus 12. And you might be wondering, 3x got canceled. Okay, so once canceled, this one is just 2 equals negative 12, and which doesn't make sense. So that means x has no solution. So this one, there's no solution can be found. So this one is just one of the tricky ones. So just saying that, you know, using the trisections theorem, the definitions, to get that the value of x. Okay, so now here's another one. Find the value of x and PQ. Okay, so started off with x squared plus 4. So using that, the segment addition postulate. So basically what this one is saying, that PR is the sum of PQ. Okay, so not RQ, PQ. So segment PR is the sum of PQ and segment RQ. So basically combine those two segments together, the measurements, and then you want to set that equal to 13. So you may notice that this one is a quadratic equation. So x squared plus 4x. Combine the like terms, the constant, so plus 1. And then you want to bring everything together to one side. The way to solve for the quadratic equation, either you want to factor, complete the square, or using the quadratic formula. So before you do anything of that, so you want to bring everything together to one side, and the other side you want to set that equal to 0. So 1 minus 13, so then that'll be negative 12. And is this factorable? So let's see. So we do know that 6 times 2 would be 12, so we need one of those numbers positive, negative. So that means x plus 6, and then x minus 2. Okay, so you can always use the smiley face as what I talked about for the other video, the way to factor it. So this one set equal to 0, so we do have x equals negative 6, x equals 2. But the things that you need to plug in a number and check. Okay, so segment, it's always considered a positive number. So this one, there's no way this one can be negative, because by the time you plug in negative 6 to one of the segments, so we got 4 times negative 6 minus 3, which is negative 24 minus 3, it's negative 27. So segment, the unit, the distance cannot be negative, so this one, it doesn't make sense. So x equals negative 6, that would be the extraneous solution. Extraneous, that means it's an invalid solution. So the only solution we have is x equals 2. So once we find that, x equals 2, and also what else do we need to do? Find out PQ. So PQ, plug in the number back to the original expression. So PQ, so it's x squared plus 4. So plug in 2, so 2 squared plus 4, so 4 plus 4, so we got 8. Alright, and now let's see what else that we got for the rest of this. So here's another page for that one of the examples. So given that ray QP, so QP and QR trisects angle NQS. So anytime that I see things that's kind of complicated, or things that's kind of like there's so many information given here, so you want to draw the diagram first. So angle NQS, and then we do have two rays inside the angle, so one is QP and the other one is ray QR. So again, trisect, that means all those three angles got to be congruent. So that means angle NQP, okay, NQP, it's going to be the same as the one for PQR, and also is the same as angle RQS. Okay, so what we need to do, so we just want to set that 3x minus 2y equals x minus y equals y minus 10. So you might be wondering two variables, so this one definitely we can set up the system equation. So the first equation would be considered 3x minus 2y equals y minus 10. And then the other one is x minus y equals y minus 10. Okay? So basically this one, we can just solve for y and x. So started off with that, the line up here, so bring it back to the standard form. So subtract y, well, let's see those two equations. So subtract y both sides. So what we found here, it's 3x minus 3y equals negative 10. And then the other equation here, so this one, subtract y both sides, so we do have x minus 2y, okay, x minus 2y, then that equals negative 10 as well. So you might be wondering, these two equations, well, it looks like they're kind of the same, so we can apply substitution. But substitution again, so you're just like getting back to the original equation. So what we need to find out here is that the common coefficient. So 3 and 1, so the least common denominator would be 3. So what I can do here, so multiply the second equation by 3. Okay, so let me use different color for that one. So what we got here is 3x minus 6y equals negative 30. And then compare that to the first and the second equation. So 3x, that's what they share in common. So what we can do here, subtract. So 3x minus 3x got cancelled. So negative 3y minus negative 6y, then that'll be 3y. Because negative times negative, then that'll be positive. Negative 10 minus negative 30, then that'll be considered positive 20. So y equals 20 over 3. It's not a nice number, it's improper fraction. You can always convert that to a mixed fraction. And this one, usually, we just leave it as the improper fraction. But make sure that got to be in the simplest form. So after we solve for y, so we can solve for x. So the way to solve for x, so we just use the original second equation. So x minus 2 times y, so 2 times 20 over 3. So that equals negative 10. So x minus 40 over 3 equals negative 10. So if you don't want to deal with the fraction, you can always multiply everything by 3, both sides. So what we found here is 3x minus 40. So that equals negative 30. So negative 30 plus 40, then that'll be 10. So x equals 10 over 3. Okay? So the way to solve for x and y. So you might be wondering this setup here. So looks like, if we plug in a number back here, so the solution would not be valid because that the inequality, the expression for that, the quantity. So 20 over 3 minus 10, so that means the angle is going to be considered negative. So negative angle. Okay, so check that. So there might be a little typo right here with the expression set up. But the way to solve for this, so usually once you come up with that, the angle, it should be positive. Positive, all positive. Okay, so any questions that you have, so you guys are more than welcome to put up the comments, questions on my YouTube channel, for this video. And also, if you guys do like the video, so please subscribe it. So I'll see you next time. Okay, you guys have a great one.